Now, in this section, we're going to be doing a lot of sketching of graphs of polynomial functions. All right, and in order to sketch polynomial functions, there are a few different things that we're going to have to look at. One, we're going to have to think about finding the zeros of the function. All right, zeros are also known as x-intercepts, as you guys know. All right, we'll talk about that a little bit later on. And then we are also going to have to figure out what the end behavior of the graph is going to be. And when you hear the words end behavior, that means what does the graph do as it goes to the right, and what does the graph do as it goes to the left. And for polynomials, your options are either going to be the function is going to rise to the left or fall to the left, and the graph will either rise to the right or fall to the right. And we can determine that by using the leading coefficient test. All right, so to use the leading coefficient test, we need to identify the leading coefficient of the polynomial as well as the degree. Okay? If the degree of the polynomial is odd, that's an odd number, 3, 5, 7, 9, a number that is not divisible by 2, the graph of the function will rise to the right and fall to the left if the leading coefficient is positive. Right? The function will rise right and fall to the left if the leading coefficient is positive. Or the function will rise to the left and fall to the right if the leading coefficient is negative. All right, so keep in mind that both of these cases are for an odd degree polynomial. Okay, the degree of the polynomial is an odd number. So here are a couple simple polynomials to think about to remember these rules. All right, here we have the graph of y equals x cubed. Notice this is a third degree polynomial. 3 is an odd number, and the leading coefficient is positive. All right, this graph rises to the right, and it falls to the left. The same end behavior will be true for any odd degree polynomial that has a positive leading coefficient. Similarly, here we have the graph of y equals negative x cubed. This graph is the same as y equals x cubed, but we have reflected it over the x-axis. And notice the graph now rises to the left and falls to the right. Okay? Any polynomial that has odd degree and a negative leading coefficient will have the exact same end behavior, rising to the left and falling to the right. Now, let's talk about even degree polynomials, right? If the degree of the polynomial function is even, 2, 4, 6, 8, any number that is evenly divisible by 2, all right? That's an even number. The graph of the function will rise to the right and rise to the left if the leading coefficient is positive, or fall to the left and fall to the right if the leading coefficient is negative. All right, so again, with the leading coefficient test, you have to look at two different things. You must identify the degree, whether or not it's even or odd, and you must identify whether or not the leading coefficient is positive or negative. All right, so here are two basic graphs that will help you to remember, all right, these two rules. Here we have the graph of y equals x squared, right? You guys all know what this graph looks like. We have a parabola that opens up. This graph has an even degree, the degree is 2, and the leading coefficient is positive. It goes up to the left and up to the right. This means that any other polynomial with an even degree and a positive leading coefficient will rise to the left and rise to the right. Similarly, we could take that graph and reflect it over the x-axis. Here we have the graph of y equals negative x squared. And as you guys know, that's a parabola that opens downward. This falls to the left and falls to the right. Well, if you can remember this shape, we know that any polynomial with an even degree and a negative leading coefficient will fall to the left and fall to the right. All right, and so that is how we apply the leading coefficient test. We need to identify the degree of the polynomial and whether or not the leading coefficient is positive or negative. Let's look at a couple examples here where we put this to use. Determine the end behavior. And again, end behavior means what happens as it goes to the right, what happens as it goes to the left of the following polynomial function by applying the leading coefficient test. So here we have the function f of x is equal to 7 minus 5x to the fifth minus 3x to the eighth plus 3x. So we have to figure out what is the leading coefficient and what is the degree of the polynomial. One thing that's a little bit tricky here in this particular problem is that our function is not written in decreasing order of power. All right, so keep that in mind. What is our highest power of x? Well, our highest power of x is 8, which means that this term right here, this negative 3x to the 8th power, is the term that we want to be looking at. All right, this tells us that the degree of this polynomial is 8, and the leading coefficient, that's the constant multiple that comes in front of our highest power of x, all right, is negative in this case. In this particular case, it is negative 3. So we have a degree of 8 that is an even degree, and we have a negative leading coefficient. If this is the case, even degree and negative leading coefficient, that means that our graph is going to fall to the left and fall to the right. And if you were to plug this into your graphing calculator to check your work, all right, we could certainly see, yes, this graph goes down to the left and down to the right. That is how we apply the leading coefficient test. Again, we need to identify the degree of the polynomial and whether or not the leading coefficient is positive or negative. Let's look at one that's a little bit more complicated here. Here we have the function f of x is equal to 3x minus 5 times x plus 1 to the fourth power times 5 minus x quantity squared. Determine the end behavior of the polynomial function. Now, one thing to recognize here is that, yes, this is a polynomial function, but it's actually written out in factored form. All right, these are each of the individual factors. We have 3x minus 5 times the quantity x plus 1 to the fourth times the quantity 5 minus x squared. All right, this is the factored form of this polynomial. So if we want to know the degree and the leading coefficient, we have to figure out what the highest power of x would actually be if we were to multiply all of this out. Now, do you need to expand this completely? The answer is no, right? That would take a long time, right? Even expanding x plus 1 raised to the fourth power, that would be x plus 1 times x plus 1 times x plus 1 times x plus 1. All right, we'd be here all day trying to multiply all of that out. But we can do a little shortcut just by analyzing the highest power of x in each one of the individual factorings. So notice in this first factoring, I would end up with my highest power being 3x. In the second factor here, x plus 1, I have x plus 1 raised to the fourth. If we were to multiply all of that out, in which we are not going to do, all right, the highest power of x that we would end up with would be x to the fourth. And here we have 5 minus x quantity squared. Well, if we were to multiply that out, notice we'd end up with a negative x times a negative x. And that negative x times a negative x would leave us with a positive x squared for our highest power of x. And once we multiplied those, we would then have to multiply all of these powers together as well. All right? And hopefully you remember that when we multiply exponential quantities with like bases, we add the exponents. So 3x times x to the fourth would give me 3x to the fifth times 3x squared gives me 3x to the seventh. All right? This would be the highest power term of our polynomial function, 3x to the seventh. And so what is the degree of this polynomial? The degree is going to be 7. That is odd degree. And the leading coefficient in this case is a positive 3. All right, so we have odd degree and positive leading coefficient. What does that mean for our end behavior? the graph is going to fall to the left and rise to the right. All right, and as you can see here, the graph certainly does that. It's going to fall to the left and rise to the right. There you have the leading coefficient test. Again, remember you have to identify the degree of the polynomial and whether or not the leading coefficient is going to be positive or negative. In the next videos, we'll talk about the zeros of these polynomial functions. Coming right up.